Here we are, day 2 of the polar unit, and today we're going to take a step at hopefully graphing some of these equations. So we'll see what that amounts to. A little bit of review first off. So see if you can plot out these points. You've got A, B, C, D. You should be pros at these if you did your delta math. All right. Take and hit pause and then come back. All right, here are the answers that I had. And answers look like 5, 11 pi over 6. So I moved 11 pi over 6 around my polar grid and plotted out 5 units from the pole, giving me point A. Did your point B come out into quadrant 2? Because we would have moved -7, swinging around this way, -7 pi over 6. And then 4 is positive, so it stays where I landed with my angular motion. And then part C, that had pi, so I came out, or I swung around to pi, out 7 units, but it was -7, so it bounces it back across the pole, through the pole, over to the polar axis, actually. And then D, let's see, we're moving -5 pi over 3, -5 pi over 3 swung me around to this side, but then I noticed it was a -10, so that bounced me through the pole across the opposite side to D. Find the rectangular coordinates for each of these following, for each of the following polar pairs. So, do we have 2 of these to do? Nope, just one. Okay, so let's do this one. We know this is coming in an R theta ordered pair. And my R is that I want to swing it back into, I want to get back to XY. Sometimes just, grounding yourself, what am I trying to accomplish here? I know that X equals R cosine theta, and I know that Y equals R sine theta. In there, I should be rocking and rolling. 6 cosine 2 pi over 3. Y will be 6 sine 2 pi over 3. X will become 6 cosine 2 pi over 3. Cosine of 2 pi over 3 lands me up there. That is a -1/2, is it not? And, oops, not divided. Make that multiplied. And that's going to give me -3. And then Y equals 6 sine of 2 pi over 3. That is a positive, and that's a √3 over 2. Looks like that'll be a 3√3. So final ordered pair, rectangular style, would be that. All right, next on our list, that's a little review. Give the rectangular coordinates below, find the polar coordinates, and we have to satisfy the given conditions. Oh, they're getting picky on us. This is indicating to me that I need to express my point as a positive R value. So I've got an XY. I need to get R, so that's going to come from an R equals square root, only the positive this time, right? Because we wanted positive Y, so an X squared plus Y squared. Looks like this is going to be a 9 plus a 16. Oh, how lovely. R equals 5. So I'm going to stick with the positive 5. And then to get theta, we work with tangent, don't we? So tan of theta is equal to y opposite over adjacent, so y over x. And that's going to give me a theta inverse, or inverse the tangent, and that gives me theta, and then a tan inverse of -4/3. Using my calculator in radian mode, I came out with, oops, let's make that a positive, 0.927, which if you wanted to convert that, that's about 53 degrees. So that would be in quadrant 1. And I've got to stay in the first revolution. Okay, so now what I'm going to do is think about what quadrant I need to be into. The quadrant that I am looking at, positive x, negative y, would be quadrant 4. And if I plotted out this won't get me in quadrant 4, will it? A 0.97 takes me up there. I think what I need to do is a negative. But I can't do negatives because I'm locked into positive thetas. All right, so essentially, what do I want to do? I want to be here. I want to move by negative 9.927 for that theta, and then stay with a 5 there. So what if I did full circle at 2 pi and then back off this little dab here, right? If I back that off, that should land me where I need to be. So I'm going to go 2 pi minus 0.927. And doing that, I didn't do it right yet. So let me grab a calculator. I'm going to pause for a moment. Okay, I'm back with you, and doing my calculator looks like I came out with 7.210. So my ordered pair for this is going to be positive 5, because I was restricted on that, and then a 7.210. That is not correct. I see I've got double negative, and I was thinking that's bigger than 6.28. That can't possibly work. Here's what I think I did. I didn't want this negative here. We just want to subtract that. Now I'm liking it. Okay, so let's go with a 5.356 radians, and that will land me down into quadrant 4. It's all beautiful. All right, the last one, I am going to erase everything, and R has to be negative in this case. Ah, sweet. Okay, so R equals negative square root. I need to take x and square it. That's going to be a 9 times a 2 over a 4 plus a 9 times a 2 over a 4, because basically I have to square each of these, right? And 2 and a 2. So I get 9 halves and 9 halves, which would be square root of 18 halves. Oh, how beautiful is that? Square root of 9. Looks like our R is coming in at negative 3. Okay, I'm going to hold on to that thought. R equals negative 3. Now we got to go find our theta. Tan theta equals y over x, same over same. That's going to give me a 1. That can occur at pi over 4, and also in the third quadrant, which would be 5 pi over 4, because they would both be negative x and negative y there, so 5 pi. Now, we need that. This is a quadrant 3 point, right? So I need my polar point to end up in quadrant 3. If I have to use a negative r, that means then I need to be branched out into quadrant 1 so that it reflects over to quadrant 3. I'm going with the pi over 4. So negative 3 pi over 4. There it is, the beauty of it. Nice. All right, number 7. Oh, this is some new stuff, I bet. Change the following polar equations. We were doing points before. Now we're doing equations to rectangular equations. So what is R10? That means radius equals, or radial length equals 10. And let's swing it back into rectangular. So one thing I do know is that r squared could be related to x and y squared. So let's square both sides and get r squared equals 100. And then instead of r squared, let's substitute and get x squared plus y squared equals 100. Oh, I recognize this as a circle with radius equal to 10. Well, that's what this was, wasn't it? Radius was always 10. If radius is always 10, then it's going to plot out with every angle measured possible and trace out a circle for us. Okay, that was pretty easy. Liking that one. This one, r secant. Well, I'm not good with the secant, so I'm going to change that over to a cosine. We know we want to get it into x and y. Cosine could be written as what? I'm just kind of stabbing at things right now. I'm in my head thinking I could write cosine as r x over r, couldn't I? That this would be x divided by r equals a cosine theta. Could use that. I could do some conversions and square both sides. I might still need to do that, but I think what I'm going to do first is just convert my cosine. And I'm going to convert it into an x over r. And we all know that dividing by a fraction is like multiplying by the reciprocal. Ooh, I'm going to get 1 equals 5x. It's a little weird, isn't it? Just wondering where I wanted to go with that one, you guys. I thought I should end up with x equals 5. So I got to dig in and see where you probably saw my mistake. I just saw it too. Here I could divide by r's, and I did, and that's what gave me the 1. The problem is x sits on the bottom here, not multiplied. That's a 5 over x. Now let's multiply both sides by x, and we get x equals 5. There we go. Vertical line, x equals 5. So this too is a vertical line, is what that's telling me. Now that I'm looking back at it, why didn't I just multiply by cosine theta? Cosine theta, maybe some of you saw that direction. And then r cosine theta would have been an x. It would have canceled over here, giving me x equals 5. A little bit more of a direct route on that one. Okay. On to the next problem. Okay, for the next one, I have r equals 7 sine theta. Okay, so let's do that same conversion. Let's say r equals, if I divide it by sine, equals 7. Sine is r. R sine, that's not going to work. Sine is y over r, isn't it? Could do that. R over sine. Where's that going to take me? Then I'd multiply. I could divide by r, then I'd have 1 equals 7 over sine. Sine equals 7. That's not so cool, is it? Moving around on these, you can tell it's not the easiest. That's just not leading us down the right path. What if we introduce, let's get an r on both sides, or an r squared. So I'm going to multiply both sides by r. At least I think this way I can get x squared plus y squared. At least we're heading into rectangular. And then I could get 7 r sine theta, but r sine theta is y. Okay, this is working out. Sometimes this is, the technique that you might want to employ. Now I could bring that over to this side. That would equal 0. And you're like, well, I still don't really recognize it. It is in rectangular technically, right? It's got x and y's. Let's keep delving just a little bit deeper. And I'm going to do a little complete the square here. Yeah, 7 halves. 7 halves, take middle term divided by 2, that's 7 halves, square it. That would give me a 49/4, wouldn't it? And since I added it to one side, I add it to the other. And now this creates a perfect square trinomial. So I'm going to have an x squared plus y minus 7 halves was the perfect square, getting us the 49/4 equals 49/4. So we have an r value on the right. Actually, it's r squared, isn't it? R squared of 49/4, which would be 7/4 for an r. And I know my center of my circle is 0, 7 halves. That wasn't easy, but it's doable. It is a circle. All right, on the back side of your notes, change the following rectangular to polar. Well, 11, do you recognize that equation? I recognize it. It's a circle. Let's replace x squared plus y squared with r squared. And then we can say r is either plus or minus 11, square root both sides. And it doesn't matter how I plot out my positive r. And then if I were to do negative r, I would have started over here but bounced over here, probably going something like that. So really two equations that work. plus and minus r. Okay, y equals -5. We want a horizontal line here. Well, let's replace r with our y with r sine. So r sine theta. Hey, at least I'm into r's and sine thetas. Now, most of the time in rectangular, we like to have y equals equations. So in polar, we like to have r equals equations. So polar, we like r equals equations. So that's what we're going to shoot for here. That just means we need to divide by sine, doesn't it? And we all know that dividing by sine, 1 over sine is cosecant. Okay, so -5 cosecant of theta. Horizontal line in polar. Some of these, especially in BC, we start memorizing out what these equations are just for our own benefit. It makes it a little easier. All right, the next thing, probably subbing x and y with our r cosine theta. I know that's going to get squared, equals 10 r sine theta. Well, this would be an r squared cosine squared theta equals 10 r sine theta. Now, keeping in mind, want to get r's, so let's divide by r, and we'd have r cosine squared theta equals 10 sine theta. And then I would divide by cosine squared. Sine squared over a cosine squared. Technically, we have a polar equation. Now, I'm sure we could make that look a little nicer. Sine over cosine. Sine over cosine, is that tangent? Yeah, opposite over adjacent. That's tangent, so I could have a tan. This could be like 10 tan theta, and a 1 over cosine is a secant theta. Could write it like that. It's hard to decide where to stop on that one. So this would be fine. This would be fine. Lastly, we get a slanted line, right? It's a linear function. Debating about subtracting 2x, squaring both sides. I think just substituting, maybe r sine theta equals 2r cosine theta minus 1. If I brought the cosine over, I could pull out an r. I'm just thinking r equals, right? I need to get my r's together so that I can GCF out an r. Let's GCF that r. That's going to leave us a sine theta minus 2 cosine theta. It's a lot of algebra work, isn't it? And a little bit of playing around in your mind, trying to see, well, if I did this, that would happen, and that would make this happen. So it's a trial and error for sure, as much of the mathematics is for us, right? You don't always guess the right path the first time. That looks fine to me. It's r equals, and I'm happy about that. All right. Lastly, it says identify the polar graph. Circle with center at pole, circle with center at x-axis circle. I don't know. Oh, these are all, got it. Okay, so the ones down below, I think, are all some circle equations. Most all of them, not all of them. And I want to just show you how we can plot points like we would have done in rectangular when we first started learning equations and what their shape was. So this is a 6 sine theta. I would probably start at 0. Whoops. 0 is going to be my input, and maybe, you know what, pi over 6 isn't too bad. Maybe, well, pi over 3 we could do. Pi over 2 would be nice, wouldn't it? And then, you know what, I think I'm going to do a 5 pi over 6. I'm running out of space. And then a pi. I'm going to finish it with pi. Now, let's put those into our equation. Put those in the equation to get our ordered pair. 0 goes in, sine of 0 is 0. So that's going to be an r equals 0. That's going to plot right at the pole. Then pi over 6 goes in. Sine of pi over 6 is half. So this would be a 6 times 1/2. Looks like that turns out to be 3 on the pi over 6. So now we're plotting points, and that's why we had to learn to do those. 1, 2, 3 on the pi over 6 angle. Pi over 3 angle, this one is not going to be quite so pretty. That's a root 3, so I'd have a root 3 over 2. That's a 3 root 3. 3 times square root 3 gets me a length around 5.2. So on pi over 3, 1, 2, 3, 4, 5.2. So slightly bigger than that. Let's make a big fat dot. And then pi over 2, well, we know that's where sine is 1, so this would get to 6. That's going to step out right there. There will be some symmetry, you guys. At pi, I'm back to 0. But I skipped a lot of things in between tonight. 5 pi over 6. Oh, let's do 5 pi over 6. I skipped that. I knew this was coming back to 0. 5 pi over 6. 5 pi over 6 is a half again, so I have 6 times 1/2 equals a 3. 5 pi over 6, 1, 2, 3. This forms, if we would have put more points on, we would have had a circle, a better circle. But it does form a circle. This is a circle. Symmetry about the pi over 2 axis, or the y-axis. And it is on the above plane because of the positive 6. So 16, when I go to 16, it's negative 6 sine of theta. So let's go 0, pi over 6. Using these same values, 5 pi over 6, and then we'll jump to pi. We'll put them in here. We'll get 0. 0 comes out. Pi over 6, well, it came out as 3 before. It's going to come out as negative 3 this time. Pi over 3 came out as a positive, so I multiply by a negative. This is going to be a negative 5.2. Pi over 2 is 1. This is going to come out as a negative 6. And this will come out instead of as 3. This will come out as negative 3. Putting in pi gives us a sine of 0. Sine of pi is 0, so that'll be there. Now let's move the talker out of the way. All right, 0, 0. I can plot 0, 0. Pi over 6, negative 3. This is that bounce over, isn't it? Bounce through, and 1, 2, 3. Now I'm plotting here. So this is actually going to start tracing in that direction. At pi over 3 was here. It's going to come across, so we're back over on this side with a negative 5.2. Oh, I lost my track. 1, 2, 3, 4, 5, right about there. Here's my next point. And then at pi over 2, we're at 6. There we go. There is symmetry, so this point at this point will map to there. Perfect. This point will map to here and then back home. So now I get a circle. Symmetry about pi over 2. But it is below the polar axis. And that is because it had that negative 6 going on. This one was above polar axis. All right, just a couple more. R equals 4. R equals 4 tells me that no matter what I use for theta, it doesn't really matter because R is locked in at 4. So all of these are going to be 4s. And I said I'm going to plot out a theta of 0 and 4. 1, 2, 3, 4. At pi over 2, it's 4. 1, 2, 3, 4. At pi, it's 4. At 3 pi over 2, 1, 2, 3, it's 4. Back home at 2 pi, it's 4. This gives us a circle centered about the origin. Any R equal is always going to be circle centered at the pole rather than origin, I guess. Okay, that was an easy one. Theta equals negative 3 pi over 4. Negative 3 pi over 4 would be back in here. And r can be whatever it wants. So we get every r, which essentially gives us a linear function. Has an angle to it, doesn't it? All right, so it's a line. Now, 6 cosine, I think, is our next one. Let me move me. 6 cosine. So we could, whoopsie, do an ordered pair. If we get the first one, I think the second one will fall in place quite easily. Let's do theta, r, and let's start at 0 cosine. Cosine's pretty easy at pi over 3. Pi over 2 is pretty easy. 2 pi over 3 is pretty easy. Pi is definitely in the running, isn't it? Oh, let's give that a shot. Okay, so we put in 0. Cosine of 0 is 1. That's going to turn out to be 6. Let's go plot. Angle 0, 6 units out. 1, 2, 3, 4, 5, 6. Pi over 3 is cosine of pi over 3 is 1/2. So I get 6 times 1/2, 3. So on the pi over 3, I needed to be out 1, 2, 3 units. Okay. At pi over 2, ooh, that's a 0, isn't it? I need to come into the pole. At 2 pi over 3, cosine's going to be negative on that one, isn't it? So I'm going to have 6 times negative 1/2, getting me a negative 3. Okay, this hopefully will work. At 2 pi over 3, here's my line, but I need to be on the opposite side with that negative 3. So that bounced me across 1, 2, 3. Ah, the symmetry. See the symmetry between those points? And then at pi, cosine of pi is negative 1. So it's going to be 6 times a negative 1 gives us a negative 6. So I was out here on pi at negative 6, but I got to be at negative 6. Going to bounce me back across. So started there, wraps around. It is a circle. It's symmetry because it's cosine. It's symmetrical with the x-axis or the polar axis. And it is on the right side of pi over 2 axis because 6 was greater than 0. 6 was positive. That's going to keep us over on the right side. So I bet you can guess what the negative 6 is going to do. It's going to push us over. Let's just do this one quick. 1, 2, 3, 4, 5, 6. Going to be a circle over on the left side. All right. So you have, I think, a worksheet following, and you can go ahead and work on that today. Have a good day. Oh, find the stop button.